So, math magicians, on this beautiful day, we're going to be looking at how to solve multi-step equations with variables on los dos lados. So, for some reason, I printed gold twice. So I'll delete that. And our first example, we're going to solve the equation, and we're going to check the solution. So one thing that we can do here is I am going to subtract 6x from both sides, although I had other options. But what's the purpose? What's that? We're going to call that collecting the variables. We're going to collect the variables. Other people say gather variables, but I think collect the variables is a more common way of writing it. Now, while we're here, we can get rid of the other one too. Notice that the 6x on the left side is going to drop out. And notice we can also, while we're here, move the constant to the other side as well. So we're doing 2 steps in one. We're kind of crazy like that. So in the end here, we get 24 is equal to 2x. And I'll show the work, but you don't have to show this. I'm going to divide by 2 here in order to isolate the x. So I need to divide the other side as well. In the end here, I get x equals 12 or 12 equals x. Commit to it, put a ring around it. Just to provide the steps, what I did after I collected the variables, I then divided both sides by 2. You could also say I isolated the variable. I isolated the variable. So I collected the variables, and then I isolated. Now, of course, as important as going through the process is checking that you are good to go. So remember, when you check, you always check with the original problem. So 6 times x plus 3 equals 8 times x minus 21. But instead of x, I'm going to replace it with a 12. Officially, there's actually a question mark here. I don't know if they're equal, but if you don't put the question mark there, it's not anything against. So I end up here getting 72 plus 3. On the right side, I get 96 minus 21. And you could have used a calculator real quick to multiply those out. And lastly, we add things together, 75. And hopefully we get 75 here. 9 minus 2 is 7. 6 minus 1 is 7. So the check does indeed work. Notice I'm not going to circle. Don't circle this here because that's not the answer. That's not the solution. The solution is x equals 12. So in this problem, example number 2, we're asked to solve the equation. We're going to check the solution. So I do see parentheses, and parentheses are a little bit prohibitive. So I'm going to get rid of the parentheses by distributing there. In doing that, I get 2c minus 6 equals 9c plus 2. Good. Don't just get into habits like this. Notice I intentionally messed up, so we can just double check our work. All right. Now it's actually correct. So the first step I did was use the distributive property. Use the distributive property. And actually the point of that is to get rid of parentheses. All right, next. I'm going to do 2 steps in one, just like I did before. And I'm not always going to do subtract the left and go to the right. But because the 9c is larger, kind of like the Earth compared to the moon, that I'm going to have this guy gravitate towards the 9c. So I'm going to subtract 2c from both sides right here. While I'm doing that, let me move the constants to the other side. This 2 over here is going to shift over to that side there, just to move away from the vile variable. So on this side, I get negative 14 because negative 12 minus 2 is negative 14. And on this side, I get 7c minus 2c, 9c minus 2c, which is 7c. Positive over there. So what did I do here? I collected the variables. And lastly, I'm going to divide both sides by 7 to isolate the variable. I get a -2, and I get a c right here. Isolate the variable. And now we want to check. The check, of course, just like we did before, I start with the original problem, and I erase and replace. The c becomes a -2. So I'll do the check over on the side here. So 2 parentheses again, minus 6 in parentheses equals 9 parentheses plus 2. And I'm going to substitute the value in there, -2 each one there. According to the order of operations, don't distribute first. It's not illegal, but order of operations, we should deal with the inside parentheses first. So the 2 stays outside, and the -2 minus 6 gives you -8. Over here, I can multiply. These two multiply to get -18 and bring down the +2. Now, on the right side, I'm going to combine those to get -16. And on the left side, I multiply to get -16. Ka-chow! We got it. So I know, not just think, but I know the solution is -2. And the two solutions here, D is 2, and the other one here, D is +9. Let's take a gander now at stuff that is more complicated. So, what does your instinct say about what needs to be done here? So just to run through some options here. Number 1, we could convert this to decimal just to not have fractions. Somebody else said we can add 7 to both sides. And somebody else said, well, let's just go ahead and start distributing. All right, these are all true. The one I'm going to go with is going to be, I want to get one side by itself. So I am going to add 7 to both sides right here. Bring down the 1/2. And somebody might say, but Swenson, why don't we just distribute right there? Well, I don't want to distribute because I now get more fractions. Sending the fraction around might complicate and give me more fractions. So watch the magic here. How can I get rid of the fraction without sending it in? Well, if we multiply both sides by the reciprocal, which is the same as multiplying by 2 here, and whatever I do to one side, I have to do to the other. Wait, Swenson, you wrote that as a 2/1, and here you wrote it as a 2. Yeah, because they're equivalent. I didn't need the over 1. Maybe right here I just wanted to see it, but here I don't need it. So on the left side, the fraction reduces entirely. It's gone, so I'm left with just the n minus 4. On the right side, I get to distribute that 2 there. So now I have -4n plus 26. Now let's finish this up. Easiest if I add 4n to both sides. And while I'm here, let me go ahead and add the 4 here so that the constant gets deleted on the left side. So now I'm left with 5n on the left, and I have 30 on the right. Over here, I need to divide by 5 in order to isolate the n. Whatever I do to one side, I do to the other. So I get n equals 6. So this is my solution. And do a mental check. So let's walk through a check real quick. If I plug a 6 right here, I get a 2. Cut that in half to get a 1. Subtract 7 to get a -6. So just keeping that in my back pocket, I know everything adds or multiplies out to -6. Now let's continue our journey on the right side. Plug a 6 right here to get -12. Plus 6 gives me a -6, so my mental check is confirmed. Now take a moment here to work through this problem. Now we're going to walk through a way this may be used. Now this, of course, is not necessarily how you listen to music. You've got YouTube, Spotify, etc. So let's just pretend there's this service here where Cameron pays money to own music. I do have a change to make, so please change this exclamation point to $1. Cameron pays 95 cents per song with his current music service. A new download music service charges 89 cents per song, but with a $12 joining fee. So should Cameron switch to the new service? So what we want to do is take a look at the two services. We're going to call this service A, and the new service, we're going to call it B. So we're just going to look at two scenarios and consider when they are the same. So first off, the variable needs to be defined here, and the variable here, it says he pays per song. I don't like to use S's, so I'm going to say N is equal to the number of songs downloaded. Number of songs downloaded. Okay, so the first one is a very straight up situation. We have 95 cents per song, so simply we just say 95 cents and then per song being my N. At some point in time, both these music services will be equal. However, B charges a little bit less, 89 cents per song, as we see, 89 cents per song. So that one would be 89 cents per song. However, there is an additional fee to join. So that is going to be plus $12. Okay, now at some point in time, in other words, when he downloads N number of songs, let's pretend it's 100 songs here, 100 songs here, that means it's going to be the same. So right now, this one is cheaper than B. But at some point in time, B is going to be less expensive. When is that? That's going to be N. So here I can subtract 89N, 0.89N from both sides. So this one gives me 0.06 equals 12. Let's just practically think about what this means. This says here that there is a 6-cent difference between the two downloads. So part B is cheaper by 6 cents. So the question now this one answers is, when will the 6 cents difference make a difference? Because it's got to account for the $12. So now we divide both sides by 6 cents, which is $0.06. And then our end result here is that N equals 200. So let's come back and bring that into context. N equals 200, so 200 songs must be downloaded before he switches. Before B is a value. Okay, so after 200. So he's got to be predictive because he can't just switch over. If he does, I mean he can, but if he does choose to switch over, do 200 songs, then switch over here, he still has to make up for that $12 fee. So he has to download another 200 songs. So he's got to make that decision now between the two. In other words, if he's going to purchase more than 200 songs, then he's going to switch services now. But if he thinks he's not going to, then he's going to stick here. For you album buyers, just to give perspective, 200 songs, if an album is 11 songs, that only gives you about 18 albums, which may not be very much, which isn't, once a month, that's a year and a half of album purchases. So this could be a better deal overall. All right, now it's your turn. Please consider this practice problem.